So this is the collab that I made already, but I'm going to do it again with you. So please make a new collab environment, and I'm not going. I'm just using the new things. So we are going to make a one-step option pricing model here. So how can we do that? So let's first define a function. So in order to define a function, we need DEF, and then I'm going to call it say call option. And since call option is basically a function, this option gives you the option price of the current time. But in order to calculate the option price, we need to know something. And just to remember the pictures, the coin tossing examples, and remember what we needed for the explanation of the option pricing. So first we need the starting stop price S. And then in order to make the first movement, we need to know the value of U and value of D. So we also need U and D. Of course, we are going to define what D and U is later. So this is for the underlying assets, and we also need a bank account. So bank account starts from number 1, and then we need to know the interest rate for the bank account. So usually the R is the interest rate, but the CRR model use 1 plus interest rate as R. So I'm going to use their notations here directly. So R is 1 plus something. And then finally, we need to know the value of the call option at the maturity. And in order to know the value of the call option at the maturity, we need to know the stock price. I mean, we need to know the strike price of the call option, which is K. So this is the way we define a function. And it should return some values. Of course, yeah, this one does not return anything because we did not define value here. So inside this formula, inside this function, we wanted to define the option pricing formula. And what was the option pricing formula? So if you remember the one-step binomial option pricing formula, and this is for, this function is for the one step, and you can expand this one-step option pricing formula to 2 steps and general n steps. So in order to calculate this one, what do we need? The first one is 1 over R. This is the first formula of the first part of the formula. And then we need to multiply the CU, which is the payoff in the upper state, which is max U times S minus K and 0. So that was the max. And then we had a risk neutral probability. So I'm going to write it as P, but still P is not defined yet. And plus the downstate option payoff. It's, oh, yeah, I had to, and its max is D times S minus K, comma 0, and then multiplication of 1 minus P. Okay, then I'm not sure this is working or not, but I just write down the functions, and then if there is an error, I will fix it. And then in order to calculate this one, we need to know what P is. So P is, it was R minus D divided by U minus D. So, okay, and then, so this is just the definition of a function. And in order to use this function, we need to know what is S and what is D, what is U, D, R, and K. So let's just test this one is working. So call option, and we assume that S is 100 and U is 1.1 and D is 0.9 and R is 1 plus the interest rate. So let's say it's 1.05, and then strike price is say 100, yeah, and see whether it is working. Yeah, it works. It gives me some value, 7.14, and that is the option price using the option pricing formula here. So if you use exactly the same number, you should get exactly the same answer as mine, the 7.1428 something. So for example, yeah, we wanted to make our own data set for a neural network using this kind of techniques. So we define a function, and then once you have your functions, and then you can make your own data set. For example, I'm going to change the strike price for various numbers. For example, in range, say 80 to 120, and step size is 5. And then just print the core option with S is 100 and 1.1, 0.9, 1.05, and then strike price is K. So this is the for loop, and we are going to change the strike price from 80 and 85, 90 up to 120. And then when you, okay, it takes 5 positions, but 6. Question 1, 2, 3, 4, 5. Call option takes 5, but 6 were given. Yes, there is a typo. It should be 1.1, but I put 1, so it takes the, yeah. So yeah, there was a typo. Okay, I'm going to run it again. And you got all different numbers. So the first one is the call option price when the stock price is 80. And then second one is stock call option price when stock price is 95. So in order to see more clearly, say we can write K and call option value. Then we print out this one. So strike price of 80, you can get 23. Strike price of 85, you get this number, and so on and so forth. We have a bunch of numbers as our input. And then we have the output. And since we know the pricing formula of the option, we can define this function as call option function. But suppose we don't know the function inside the actual function. And what we know is just these 5 numbers and the outcome. And then you can use your neural network to find the relationship between your 5 numbers and the final option price. So that's the one way to use the the neural network.